Today's topic is your kinetic theory of gases. KTG. Kinetic theory of gases. Okay. See here. You know that whenever a gas has been heated, isn't it? So there may be an expansion in the volume and as well as of your pressure. Both pressure and volume will change. So whenever a gas is heated, okay, both pressure and volume, changes. Okay, so in this one, if I keep the mass of the gas constant and the pressure of the gas constant, we get the first coefficient called as of your volume coefficient of gas. Volume coefficient of gas. First one is your volume coefficient of gas. Clear, beta? Volume coefficient of a gas represented by alpha. It is not the alpha of your solids, beta. In the solids, alpha is known as linear expansion, beta areal expansion, gamma cubical expansion. Whereas here in the gases, volume coefficient of gas is represented by alpha. So the formula for this one is alpha is equals to your change in volume divided by original volume into temperature difference, into your temperature difference. That is alpha is equals to your volume at your T degree centigrade minus volume at your 0 degree centigrade divided by volume at 0 degree centigrade minus volume at T degree centigrade minus volume at 0 degree centigrade. So therefore I can write alpha is equals to your Vt minus of V naught divided by V naught into your T. So this is the value of your alpha. Alpha is equals to your Vt minus V naught divided by V naught into T. Vt is your volume at T degree centigrade. V naught is the volume at your 0 degree centigrade. Okay, and this is the temperature at your T degree centigrade. That is first formula you need to remember in this one. The next one is your pressure coefficient. Next one is your pressure coefficient. Pressure coefficient. Pressure coefficient represented by your pressure coefficient of gas. Keeping the mass of the gas and the volume constant, we represent it by a letter beta. So beta is equals to same like previous one. Here change in pressure will be writing. So pressure at T degree centigrade minus pressure at 0 degree centigrade divided by pressure at 0 degree centigrade into your temperature at your T degree centigrade. So beta is equals to your Pt minus of P naught divided by P naught into your T. Pt is the pressure at T degree centigrade and P naught is your pressure at your 0 degree centigrade. Again, these are the pressures. Unit for this one is your degree centigrade beta. For all gases beta, for all gases, alpha is equals to beta is equals to 1 by 273.15. This is a constant value for all gases. Okay, so these are the two standard formulas which you should remember in your expansion of your gases part of the question. Okay, the next one is Boyle's law. Okay, so next one is Boyle's law. Okay, so see, for a given gas, when you are heating a gas, keeping the temperature constant, isn't it? So they found that the pressure and volume are inversely proportional to each other. So I'm not writing the direct statement, I'm directly writing an application because already you are an LT students. So for Boyle's law, at constant temperature, pressure is inversely proportional to volume. So P into V will be equal to your constant. Into V will be equal to your constant. Okay, so that means I can write here P1 V1 will be equal to P2 into V2. Or else if I'm need writing in terms of your length, so it is a P1, area will be equal to A into your L1 is equals to your P2 into your A into your L2. इसका area cancel हो गया, so this one is a P1 L1 is equals to your P2 into your L2. So P1 L1 will be equal to your P2 into your L2. Now if it is not given in terms of your length also, I can write in terms of volume. For spherical bodies, if I'm taking, I can write here P1, volume of the spherical body is 4 by 3 pi into your R1 cube is equals to your P2. Your P2. Okay. Okay. So into your 4 by 3. Rehan. हाँ बोलो बेटा. Rehan. Rehan, tell me. Sure. So it is 4 by 3 pi into your R2 cube. 4 by 3 pi, 4 by 3 pi will get cancelled. So it is a P1 R1 cube will be equal to your P2 into your R2. So this is also one more relation of your Boyle's law. Whether you write in terms of length or you write it in terms of your volume directly, or else you write it directly in terms of your radius. So P1 R1 cube is equals to your P2 into your R2 cube. So for a given gas, when you're heating the gas at a constant temperature, pressure is inversely proportional to volume. So P1 V1 is equals to your P2 V2, or P1 A1, P1 L1 is equals to your P2 L2, or P1 R1 cube is equals to P2 into your R2 cube. So the experimental verification of this one was being done by a scientist called as of Quillbetter. So we are having an experimental verification of Boyle's law. Experimental verification of your Boyle's law. That is known as of your Quill's tube. That is known as what? Quill's tube. See, I'm trying to do first one is your general formula. Okay, so I'll first derive it for the general, then remaining all cases we can write it out. Like say, this is your y-axis and this one is your x-axis. Okay, we are taking a tube which is inclined here right now, beta. There is a tube in this one. Okay, what exactly is a quill tube, beta? A quill tube is nothing but of your test tube, something like this. This is a test tube, okay, and it is being covered by your mercury pellet. This one is known as of your mercury pellet. So that certain amount of a gas is being trapped in this one. Certain amount of your gas is being trapped in this one. So a tube in which certain amount of gas is been trapped, and this one is been covered by a mercury lead of your height, say for example h, and the amount of liquid which is been in this one is nothing but equal to your L. Ashana was boliye. Any doubt? Chalo. Okay. So experimental verification देखिए बेटा. What do you mean by actual equal tube? Means equal tube is like a test tube in which certain amount of gas is being filled or occupied. So like say मान के चलिए up to the length L, and it is being covered by a mercury pellet. This is your quill tube. Now this quill tube, what I am taking is inclined in the inclined position. ये जो है ना, I am taking in the inclined position like this. Okay, that means with the vertical, it is making an angle of your theta. And certain amount of your gas is being filled in this one up to a certain height. Okay, and it is being covered by your mercury pellet. It is being covered by a mercury pellet. Okay, the height of this mercury pellet is h, and length of this tube is, say for example, of your L, and it has been inclined at an angle of your theta. Now tell me what all forces are been acting on this one, beta. Can anyone tell me, beta? The weight of this pellet will be acting in the downward direction. Weight of this one mg in the downward direction. If I resolve this mg into the components beta, so if this is your theta, alternate angles, this will also will become for me theta. So this is right now for me your mg into your cos theta, and this side it will be your mg into your sin theta. And the gas which is being present inside this one, this will exert the pressure on this one beta. So that pressure I'm taking it as P. As it is open to the atmosphere, as this test tube is open to the atmosphere, from outside an atmospheric pressure is also acting on this. So these are all the forces which have been acting on the tube, which is inclined at an angle of your theta. One is the weight of the body mg in the downward direction. If this is theta, alternate angles, this will also be your theta. You know this one. So this one is part relation. If this is your theta, alternate angles, this one is also your theta. Okay, so if I'm resolving it here, it is a theta, so it is mg cos theta here somewhere for me right now. Please mute yourself, beta. Okay. Tell me, what all the forces are acting on this one beta right now? One is this pressure, the gas which has been filled inside when you have been heated, it will exert the pressure in the upward direction. As it is open to the atmospheric pressure will be acting in the downward direction. And weight of this mercury pellet, which is up to a height h, that is acting in the downward direction. This mg is a force, so I'm resolving the force into components mg cos theta and mg sin theta. So I can write here in equilibrium, sum of all the forces in the upward direction must be equal to sum of all the forces in the downward direction. That means sum of all the forces along this inclined plane must be equal to sum of all the forces which has been acting in the upward direction. So along the air column, if I am writing, now tell me what are the forces we are acting along the air column beta? Anyone? Along the air column, upward force is right now the pressure. If you multiply the pressure with this area of this tube is, say for example, A. So in the upward direction, the pressure is nothing but P. You multiply it with your area, that will give me the force, isn't it? That must be equal to pressure along the liquid column. That is nothing but of your P naught plus P naught into area A plus of your mg into your cos theta. Okay, because force is equal, pressure is equal to how much better? Pressure is equals to force by area. So force means I can write here pressure into area. So if I multiply with the area on this side of pressure P and P naught, we'll be getting the force. So P into A is the force in upward direction. P naught into A is the force exerted by atmospheric pressure in the downward direction. Mg cos theta is the force component along the, what do you call that, a gas which has been trapped in that one. So if I simplify this one, P into your A will be equal to your P naught into your A plus, this M is nothing but what beta? Mass of this mercury pellet. M is nothing but what for me? Mass of your mercury pellet. Mass of your mercury pellet. The height of this one is how much for me? Your H. So mass is equals to volume into density of your mercury. I'm taking it as of your rho. Mass is equals to volume into density into G into your cos theta. So this will become for me P into your A is equals to your P naught into your A plus volume is equals to volume of what beta right now for me? The liquid, the mercury which has been occupying. Volume is equals to your area into height of the liquid column is nothing but of your H rho G into your cos theta. If you see it very carefully, one of the component in this one, area is getting cancelled, isn't it? So if I remove this area particulation, I'll be writing here P is equals to your P naught is nothing but what beta? H into rho into your G, atmospheric pressure, plus this one is of your small h rho G into your cos theta, isn't it? So if I take the pressure right now here, normal pressure, P is equals to, so in this one rho into G will be your common, it will be your capital H plus of your, so rho G and rho G I have taken common, so it is your H into your cos theta. So this will be your general formula in the equals tube. For any angle, you can use this formula beta. So P is equals to rho G into capital H is your atmospheric pressure beta. I'm writing here right now, see, capital H is your atmospheric height. That is 76 centimeter of mercury column, something like that. Rho is your density of your mercury. Density of your mercury. That will be generally equal to 13.6 gram per cc. That will be equal to 13.6 into 10 to the power of 3 kg per your meter cube. Even you can write like this, meter cube. Clear beta? Is that clear? Sure. Okay, so now this is your general formula. Whenever a tube is being inclined at an angle of your theta, P is equals to rho g into your capital H plus small h into cos theta. Theta is your inclined one. Now, if theta, if the test tube is vertical in upwards, I'm writing some cases right now. You see, case number 1. If tube is open upward, if tube is opened upwards, then theta will become how much? 0. So P will be equal to your H plus of your H into your cos of your 0 into rho into G. Cos 0 is nothing but 1. So pressure will be equal to atmospheric height plus height of the mercury pellet H into rho into G. So this will be the formula for that. Okay. This is P1. The same way, case number 2. Case number 2. If tube is opened downward, if tube is opened downwards, okay, opened upward means the tube is like this. Okay, in this one something is being filled. If the tube is opened downward means like this. Okay, mercury pellet, some gas has been filled. At that time, cos theta will be equal to how much for me? 180 degrees, because you're turned by 180 degrees. Cos 180 is how much for me? Theta is equal to your 180 degrees part of relation. So theta is your 180 degrees. You're rotated by your 180 degrees. So cos 180 will be equal to how much? Theta is equals to your 180 degrees. So in the second case, when it is being opened downwards, so P2 will be equal to capital H plus small h into cos 180 degrees into your rho into G. Cos 180 is how much for me, beta? Minus. So P2 will be equal to your capital H minus a small h into your rho into your G. So this will be the formula for it. Okay. Now case number 3. Case number 3. If the tube is in horizontal position, beta. If tube is in horizontal position. If the tube is in your horizontal position. Okay, that means the tube is something like this. Okay, now see this diagram better. If the tube is completely made horizontal, theta will become how much for me? 90 degrees. So theta will become for me 90 degrees. So pressure P3 will be equal to capital H plus a small h into cos 90 degrees into your rho into your G. Cos 90 is 0. So P3 will be equal to your H into rho into G. So this will be the P3. So these are the 3 cases you need to remember for your Boyle's laws experiment part of relation. Clear, beta? Okay, if the tube is open in the upward direction, theta is equal to 0. So formula is capital H plus small h into rho into G. If the tube is opened downwards, theta is 180 degrees. So P2 is equal to capital H minus small h into rho into G. If the tube is in horizontal position, theta is 90 degrees. Then P3 is equal to capital H plus small h into cos 90 degrees rho into G. So P3 will be equal to your H rho into G. So these are the 3 cases. So rather than remembering all this one, if you can remember this standard case when it has been inclined at an angle theta, it will be easy for you to do any type of your problems related to this one. I hope you're clear with this one, better. Okay, so next one. Next one is your charge. Next one is your charge. Again, same. So when you heat the gas, it is being found that V by T is equals to your constant. Okay, and one more law which is known as of your Gay-Lucas law. Even in this one, the same condition. P by T is equals to constant. Or else we call this one as Charles law 1 and Charles law 2, anything, isn't it? So it is your V1 by your T1 is equals to your V2 by your T2. Okay, and in the same way, P1 by your T1 will be equal to your P2 divided by your T2. So these are the 2 important formulas you need to remember. These 3 laws you need to remember for your competitive examinations. That is your Boyle's law, Charles law, and also known as of your Gay-Lucas law. And ultimately in the expansion of gases, ideal gas equation. Ideal gas equation. I'm not doing the derivation of this one because this is of no use for your LT students, but first year students, if there are anyone, you can just see the derivation of this one from your material beta. Otherwise, I can tell you sometimes I've done the derivation in some other cases also. I'll try to share the video with that one. You can see it all. So for ideal gas equation, if I'm writing beta, PV is equals to N into capital R into your T. Capital R is equals to your 8.3 beta. Unit of this one is nothing but joule per your mole Kelvin. Okay, so 8.314 will take approximately, I'm taking 8.3. N is nothing but your number of moles. N is nothing but what for me? Number of moles. How do you calculate the value of N? N is equals to mass by your molecular weight or molecular mass. T is your temperature. T is your absolute temperature. Absolute temperature in Kelvin will take it. In Kelvin. Okay. P is your pressure and V is your volume. As usually, P is your pressure and V is your volume. Okay, so PV is equals to nRT. The same way, PV is equals to M into small r into T for your mass. If I'm taking in the grams, then PV is equals to M into R. R is nothing but of your specific gas constant. The remaining terms are same as usual. Okay, and M is nothing but of your mass. Okay, in terms of mass, if I am taking, then PV is equals to your M into your small r into your capital T. That is one of the important relation you need to remember in this one. Clear, beta? So next one. KTG. In KTG, the first important formula which you need to remember is right now for me your pressure formula. We're not going for the derivation for this one better. When a gas is being taken in a cubical blocks and it exerts the pressure in all the three sides of the container, Vx, Vy, V part deflation. I'm directly writing the relation for this one here right now. Pressure exerted by the gas. Let me change the color of the pen. Yeah. Pressure exerted by the gas in a closed container will be equal to how much? P is equals to your M into N into your VRMS square divided by your 3 into your V. So this is your P. P is equal to your Mn VRMS square divided by your 3 into your V part deflation. So for kinetic theory of a gases, if I'm writing kinetic theory of your gas or kinetic energy of your gas, kinetic energy of gas, it possesses translational and rotational energy beta. So if I'm writing your translational energy, translational kinetic energy. Translational kinetic energy will be equal to 3 by 2 R into your T. Just a minute, beta. Sorry, beta, I was small disturbance. Chalo. Kinetic energy of the gas beta. If I'm talking about in the translation part, we'll write kinetic energy is equals to 3 by 2 into your RT per mole of your gas. Per mole of your gas. For each gas, I can say. For each gas molecule. Okay. No, sir. For diatomic gas, if I'm writing for diatomic gas, we'll do this one all detail in the thermodynamics. For diatomic gas, if I'm taking, it will be your translational translational plus rotational. Translational plus of your rotational kinetic energy. That will be equal to your 5 by 2 into your RT. Okay, per mole. Okay, so if I'm talking about only translation for a monoatomic gas, 3 by 2. For diatomic gas, it has both translational and rotational. So it is 5 by 2 RT. Like that for the triatomic, polyatomic, that will do in detail related to this one in the degrees of your freedom part of relation. Okay, sure. The next one is very important one. So if I'm having N1 moles, yeah. If N1 moles of gas with degrees of freedom, F1 and N2 moles with F2 degrees of freedom are being mixed, then effective degrees of freedom will be equal to how much? Then effective degrees of freedom. That will be equal to how much, beta? F is equals to, see here, N1 moles of a gas with the degrees of freedom F1 and N2 moles of what you call the N2 moles with your F2 degrees of freedom are being mixed. Then effective degrees of the freedom will be equal to your effective degrees of freedom. I'm taking it as of your F beta. So F will be equal to your N1 into your F1 plus of your N2 into your F2 divided by total number of your moles. That is nothing but N1 plus of your N2. This is your degrees of freedom. F is equals to your N1 F1 plus of your N2 F2 divided by your N1 plus of your N2 part of relation. Okay. And in this one more important, which you might have been already studied in your chemistry in the states of matter, that is about your Dalton's law of partial pressure. Dalton's law of your partial pressure. Dalton's law of your partial pressure. Okay. So what is the Dalton's laws of your partial pressure, beta? If more than 2-3 gases have been fixed in a container and if all of them have been compressed, then pressure exerted by each gas will be the difference. So sum of the total pressure I can write here is P is equals to your P1 plus of your P2 plus of your P3 plus so on up to your Pn. Whatever the number of gases you are taking, accordingly we can take the relation for that. Clear for everyone? Sure. Next one is about your degrees of freedom. Next heading is your degrees of freedom. Degrees of freedom. Represented by letter F. Represented by letter F. So if I'm talking about for monoatomic gas, I hope you already know this one from the chemistry part, beta. For the monoatomic gas, the number of degrees of freedom is your 3 translation. I'm writing only the nectar, which has been important, but I don't go for much depth at right now at these situations right now. So if I'm talking about kinetic energy per mole, that will be equal to how much, better? 3 by 2 R into your T. Then molar specific heat at a constant volume will be equal to your du by your dt. That means if I'm writing this one, so this will become for me 3 by 2 into your R. Then we know the relation Cp minus Cv is equals to R, Mayer's relation. Isn't it? So from this one I can write Cp. Cp is equals to your Cv plus of your R. That means this will become for me 3R by 2 plus of your R. That means that will become for me 5R divided by 2. So gamma will be equal to how much, better? The ratio of the specific heat, a molar specific heat, a constant pressure divided by your constant volume. Cp by your Cv. Cp is equals to 5R divided by 2 divided by your 3R divided by 2. This 2, this R will get cancelled. So this will be equal to your 5 by 3. Okay, so we need to remember the standard formulas in this one beta. Cp minus Cv is equals to your R, which is known as of your Mayer's relation. RCV is equals to your du divided by dt. U is nothing but what beta? Internal energy. It is known as of your internal energy. T is your temperature. Then the same way Cp is equals to your Cv plus of your R, and gamma value will be equal to your Cp divided by your Cv. Okay, so for what type of a gas? For monoatomic gas, the number of degrees of freedom is nothing but equal to your 3. The same way for your diatomic gas, if I'm going, diatomic gas. Okay, for diatomic gas, degrees of freedom F will be equal to 5. That is nothing but 3 translational and 2 rotational. 3 translational and 2 rotational. So kinetic energy per mole, will be equal to 5RT divided by your 2. So I can write here CV is equals to your 5R divided by 2. So du by dt just TT will be getting cancelled. So we'll be getting 5R by 2. So Cp will be equal to your Cv divided plus of your R. So that will be equal to 5R divided by 2 plus of your R. So that will be equal to your 7R divided by 2. So gamma will be equal to your how much? Cp by Cv. So that will be equal to 7 by 5. I'm writing directly for this. Okay. The next one is about your triatomic gas. Third one. For your triatomic, or we can say for polyatomic gas. Triatomic or your polyatomic gas, more than 3. Okay, so if I'm writing for this one, number of degrees of freedom F will be equal to 6. So this is your 3 translational and 3 rotational. If I am taking linear, that means kinetic energy per mole will be equal to your 6 into your RT divided by 2. So that will be equal to your 3R into your T. So Cv will be equal to your how much for me? 3R, isn't it? So it will be your 3R. Cv will be equal to your 3R because du by your dt if I'm taking. Then Cp will be equal to how much beta? Cv plus of your R, that is your 3R plus of your R. So that will become for me your 4R. Clear? The same way gamma. So gamma is equals to Cp by your Cv. So that will be equal to your 4R divided by your 3R. So that will be equal to your how much? RR will get cancelled. It will be your 4 by 3. So gamma value will be equal to your 4 by 3. So these are the some of the formulas which you should even remember at the midnight of a 12. If someone asks you this question, this formulas, you should be in a position to give the answers in a fastest way. That is very much required for the kinetic theory of gases. All the formulas should be on your tip of your hands to do the numericals related to this one. Don't go in much depth. It's more than enough. Degrees of your freedom if I'm taking for monoatomic gas, for your monoatomic gas, number of degrees of freedom is nothing but equal to your 3. For your diatomic gas, it is 5. And for triatomic gas, it is your 6 particulation. Clear for everyone? Sure. In general, if I am writing better, in general, gamma value if I am taking, gamma is equals to 1 plus 2 by your F. Okay, so if number of degrees of freedom is known for me, I can write the value of a gamma. For monoatomic if I'm taking 3, isn't it? So for monoatomic if I'm taking, for mono F is equals to 3. For di it will be equal to your 5. And for tri linear if I'm taking, number of degrees of freedom will be 6. Like that you can simplify and get the values of your gamma particulation. The next one is a very important beta. Very important for your NEET. That is of your mean free path. Mean free path. Represented by letter lambda. Represented by letter lambda. Do anyone remember this formula beta? Standard formula, if anyone can remember, can anyone write in the chat box? Nandini? Can anyone tell me? No one? Lambda? I'll try. Mean free path means the distance between any two molecules which have been colliding when a gas is being filled in a container beta. So lambda is given for me by the formula. Lambda is equals to, I can say right now, the free path traveled between two successive collisions. Represented by lambda. Lambda is equals to 1 by, this one is your under root of your 2 pi into your d square into your n. Okay. So if I'm writing the values of this one beta, d is nothing but how much, can anyone tell me? It is your diameter of molecule. Diameter of your molecule. And n is nothing but your number of molecules per unit volume. Number of molecules per unit volume. Per your unit volume. That means n is equals to your capital N divided by your V. Okay. So now see here, from the ideal gas equation, from ideal gas equation, I can write PV is equals to your N into K into T in number of molecules. Okay, that means I can write here N by V. That means P is equals to your N by V into K into T. So therefore I can write N by V is also equal to your P by your K into T. K is what beta? Boltzmann's constant. So now if I'm writing the formula for the lambda, so lambda is equals to 1 by under root of your 2 pi into your d square into n will be equal to your n into your in terms of your volume V. So in terms of volume and number of molecules, if I'm writing, this is one more formula. If I need to write the volume in terms of your pressure, so lambda is also equal to your, it is also equal to your K into your T divided by under root of 2 pi into your d square into your pressure P. In terms of your Boltzmann's constant, in terms of absolute pressure, in terms of your pressure, K is your Boltzmann's constant. Clear? Is that clear? Next part. And very important term, one more, mean free time. Mean free time. Purely NCERT point beta. Represented by letter tau. Represented by letter tau. So what is a tau beta? So it is nothing but what? The time between the successive collisions, I can say. It is your time between successive collisions. Time between successive collisions. Successive collisions. So tau is equals to lambda divided by V average. Okay. So this is one more important formula we need to remember. Clear, beta? Is that clear? This will come back when we do the different types of the speeds beta. At that time we are having different cases. At the time I'll write this one. What do you mean by average velocity, mean velocity? At that time we can derive these values again once again. But just right now remember that mean free path is our mean free time is represented by tau. It is a time between the successive collisions. So tau is equals to lambda divided by your V average. Clear? Any doubt to anyone in this one? Clear, beta? Sure. See it once again faster. These are very important, but a mean free path is very important. The free path traveled between any two successive collisions is a mean free path, represented by the formula lambda is equals to under root of your pi into d square into your n. D is your diameter of the pi molecule, n is your number of molecules per unit volume, n is equals to n by v. If for my ideal gas equation, I can write n by v is equals to p by kT. R is in terms of volume and number of molecules if is given, so I can remember this formula. Or else I can remember the formula in terms of a pressure. Lambda is equals to k into t divided by under root of your 2 pi d square into your p. Clear? Sure. Gamma of your mixture. Gamma of mixture. Gamma of your mixture. That means when more than 2-3 gases have been mixed, so at that time what happens? We are not going for the much of the depth of the analysis of this one. So when Cp and Cv are being given, beta, first one, when Cp and Cv are given, so for two gases with N1 and N2 moles, N1 and your N2 moles. Okay, so when Cp and Cv are being given, when Cp and Cv are given for two gases with N1 and N2 number of your moles, I can write Cv of your mixture. Cv of your mixture will be equal to your N1 Cv1 plus of your N2 Cv2 divided by your N1 plus of your N2. In the same way, Cp of your mixture, Cp of your mixture will be equal to your number of moles N1 into Cp1 plus of your N2 into your Cp2 divided by your N1 plus of your N2. So these are the two standard formulas which you need to remember for your competitive examination. When Cp and Cv are being given, and for the two gases with your n number of your moles, if I am taking, it is N1 Cv1 plus of your N2 Cv2 divided by N1 plus N2. In the same way, for Cp of your mixture, N1 Cp1 plus of your N2 C2 N2 Cp2 divided by your N1 plus of your N2. That means if I am writing gamma of your mixture, I can directly write gamma of your mixture is equals to your Cp of your mixture divided by Cv of your mixture. Cv of your mixture. So that will be your gamma of your mixture. So gamma of your mixture is equals to Cp of mixture divided by Cv of your mixture. Is that clear for everyone? So these are some of the standard formulas which you should remember for doing the numericals. Clear? So let me give you one small numerical. Based on the standard formula. Let's write this question better. 2 moles, roughly you can do it out. Anyhow, I'll be sending you the notes. 2 moles of a monoatomic gas. Monoatomic gas are mixed with your n moles of a polyatomic gas. N moles of your polyatomic gas. If mixture behaves like diatomic gas, then find the value of n. Find the value of n. Can anyone do it better? Make it fast. We have got the 2 moles. Sir, enable your camera. 2 moles of your monoatomic gas are being mixed with your N1 moles of your polyatomic gas. If mixture behaves like a diatomic gas, then find the value of your N. So gamma of your mixture, you know the formula, beta. F is equals to your N1 F1 plus N2 F2 divided by N1 plus N2. Isn't it? So what is telling is 2 moles of monoatomic gas, N1 is 2, are mixed with N moles of your polyatomic gas. If the mixture behaves like diatomic, for diatomic beta, and find the value of N. So for diatomic, F value will be equal to how much beta? 5. N1 moles is given how much for me? 2. Number of degrees of freedom for monoatomic is nothing but 3. Plus N2 is N into N1 moles of polyatomic gas means 6, because it's not telling triatomic or linear or non-linear. So we'll be using directly a linear application, divided by N1 plus N2. N1 is how much for me? 2 plus of your N. So that will be 2 3s are 6 plus of your N into your 6, or 6N you can write, divided by 2 plus of your N. Okay, so this will be your 5 into your 2 plus of your N is equals to 6 plus of your 6N. Just simplify this one, you'll get the value of your N. So this will be equal to your 5 2s are 10 plus of your 5N is equals to your 6 plus of your 6N. So this will become for me 10 minus 6 is equals to 6N minus of your 5N. So that will be equal to your N. That is nothing but 4. So N is equals to your 4. That will be the answer. Clear, beta? Is it clear? Any doubt in this one? Sure. Next one, an important question, beta. See this question. Two containers of equal volume contain the same gas at pressures P1 and P2 and absolute temperatures T1 and T2 respectively. On joining the containers, the gas reaches a common temperature or a common pressure and temperature T. Then find the value of P by T. P by T is equals to how much? Clear? Okay, while writing question, I'm just offing out. That's it. Don't make it. Two containers of an equal volume contains the same gas at a pressure P1 and as well as of your P2. Now draw the diagram beta as per your analysis. We have got two containers. This is one container. And equal volumes. There is another container of equal volume. That means V and V. And at a pressure of your P1, and this is at a pressure of P2. At absolute temperatures T1 and T2. On joining the containers, that means when you join these two containers like this. Okay, so there is a common pressure. So certain amount of gas which has been present here, it will start moving in this one. This one is initially right now here, and this one is initially right now here. So now both of them will get the same pressure, isn't it? Then find the values of your P by T is asking. And it will attain a common temperature and common temperature also. Temperature is also becoming same. But volume will be your V1 and as well as of your V2. Volume will be your V1 and V2 because volume is same, but the amount of gas present in that one is remaining for me same. That means V1 will be equal to your V2. Then use the relation beta. Number of moles of the gas will be the same. Here it is your N1 and here it is your N2. Here it is also your N1 dash and here it will be your N2 dash. That means N1 plus of your N2 must be equal to N1 dash plus of your N2 dash. Whatever is an initial number of moles, the same should also be the final condition. So if I'm writing this one right now, initial pressure is P1, volume is V divided by temperature is nothing but of your T1. Plus this one is your P2, volume V divided by R into your T2 is equal. So next one is your pressure P into right now the volume will become how much for me better? Can anyone tell me? Volume is right now, pressure is V of becoming P. Volume will be equal to your how much? Can anyone tell me? It will be equal to your V divided by your R and temperature will be your T. divided by your P into your V divided by your R into your T. Okay, so this will be equal to your how much for me, beta? 2 times I can write. So it is 2 PV divided by your R into your T. So it's asking your P by T is equals to how much? So everywhere I can cancel this R beta. Now see here, P1 divided by T1 plus of your P2 divided by T2 into. In this one, V by R is your common is equals to 2 times of P into V divided by R into your T. Anything is getting cancelled in this one, you see better if I'm writing here. So this R and this R will get cancelled. This V and this V will get cancelled. So from this one, I can write a P by T will be equal to your. This 2 will go down. So this will become for me 1 by 2. This will become for me 1 by 2 into your P1 by T1 plus of your P2 by your T2. This will be your answer. Check it out, beta. Okay, clear, beta. Sorry for the disturbance. I hope you got the answer for this one. So P by T is equal to how much? 1 by 2 into P1 by T1 plus of your P2 by your T2. Is it clear for everyone? So this was the introduction of your KTG part relation. I'll send you the assignments today related to this one. Already assignments are always been created. So that assignments already on the app you have been uploaded. You please try to start doing the problems related to the KTG. Tomorrow we'll try to do the Maxwell's distribution law and as well as of your RMS velocity, VRMS velocities, most probable velocities for applications and then applications part affiliation. Okay, beta? Take care. If anyone is having any doubts, you can talk to me, beta. I'm also sharing you one of the link where I have kept all the heat transfer video lectures at one side on my channel also. You can just go through there also for the fast revision basically. All the heat and thermodynamics lectures I have kept at one side. And today our KTG assignments will try to share you both on the WhatsApp and as well as of your on your what do you call that one app also basically. Okay. Is it clear? Take care, beta. Bye.